Off you go, Matt.
Yeah, I will show you how you can utilize the Open Policy Agent for authorization in a service-oriented world. I have to say that I'm not a Rego developer or Open Policy Agent developer, but from an architect, I will give you the architecture point of view, and for that, I do have enough knowledge about it. I did work with it. I also did I also created policies, but I have to highlight I'm not a Rego expert, so very detailed questions regarding Rego I will not be able to answer. So for this talk, you will need some knowledge. I assume that you do have knowledge in OAuth and OpenID Connect. You know what an identity provider is and an access token. You don't need more knowledge about it, but that is what I assume. So, as I said, the topic, or we will focus on microservices here. You can do a lot of other things with OPA, but we focus on microservices. Microservices are decoupled, so they're created in different languages and from different teams. And sometimes you want to throw away a microservice and completely rebuild its functionality in another language. So no authorization, I think that everyone understands that that is not an option. So a malicious user could do what this malicious user wants to do. So we need authentication and afterwards authorization. There is a request for comments in which authorization is defined. You see two things which are defined, two entities which are defined in that RC. You have a user, and then comes a policy enforcement point and a policy decision point. So the policy enforcement points delegates the question, can I let this request pass through, for example, and then the policy decision point will answer yes and no. So that is defined. The policy decision point to perform this decision, it needs a policy and it needs a policy information point. Yeah, in addition, you might need a policy administration point for the person who is administering the policies, or the persons. Maybe it's there are multiple people. And the policy agent, you could say policy agent, to the combination of policy enforcement point, policy decision point, policy and policy information point. And that is also what the policy, what the open policy agent OPA, short OPA, is about. Yeah, let us take a deeper where you need to perform authorizations, at least from my point of view. You can have another point of view, and you can always ask when you have another point of view. Oh, I'm not having the chat open, so in case I will open the chat in case you are too shy to talk. I'm very open for you. When you want to talk and have a question, you can directly raise a question, and then we can directly discuss it. So you don't need to wait. In case you're not having the ability to talk right now, I think you can write in the chat, and then we give you the ability to interact with the speaker. Yeah. Okay. So let us continue with the topic. Yeah, in the old world, without a policy, with one policy agent in the front, you will have the decision only in the front, and that might not be a good idea. So that means also you have a lot of people managing the policies for all the services behind, but these people might not have the knowledge to actually do so. or it will result in a delay because they actually ask the people who developed, is this a good policy, or the people who develop a service need to request here, please do and do, please do and please do this or this, because authorization depends always of the context of the application. So it will always you always need knowledge of the application language to create a proper policy. Yeah, so that might not be a good idea. I have tried to visualize it a bit here. So here are all the different people who need to actually administer the policy agent, and it will be hard to do so because maybe someone creates a bug which results in open routes to different other services, or you have a malicious user outside or inside. So that is a bad idea. So what you want to do, what you don't want to do is edge security in a microservice world. What you want to do is check on each service. I said already. Yeah, so that is what you want. Actually, you have all the services here. The 4 services we saw beforehand, and they all have their own policy agent to perform policy decisions. So that doesn't mean that you can't have something like a rudimentary edge security where you check if this is a valid access token, which has a valid signature, which is still not expired, and whatever else you expect generically on such a token. That you can still do, but the authorization decision you need to perform or at the microservice level from my point of view. Yeah, you also can perform policies, decisions in the infrastructure, for example, in Kubernetes. You can define with OPA to have admissions controllers which define which registries are allowed for images and which registries are not allowed for images. Later, we will see an example for that. You can also have an envoy where you define which endpoints are allowed. And on the application side, yeah, you can perform authorization decisions. You can also identify dependency. You can identify dependency violations in your CI/CD. So you say only these dependencies are allowed, or you say these are on the backlist, and then you can define that in this Rego. Then you can utilize OPA to identify if you have.
So, Timo, can I ask a question? What
Yeah.
do you call that pattern? Because it's definitely one of the patterns that I remember arriving as, finding tons of vulnerabilities, and then, the logic would be, look, the problem here is the authorization is done far too much upstream. Right? You really need the almost the service with the right context to make the right decision, right? But what do you call that pattern? Right? Is it localized authorization versus centralized versus edge decision making? From a policy point of view, what's the name of that? Like the pattern you had on the previous slide.
I called it authorization in service-oriented world, right? So I'm not sure if there is a word for it.
No, but you could do this with a central authorization service, right? You could, because this is localized authorization, right, inside the service, isn't it?
It's not inside. We were at it, as you can see on the picture. It's kind of attached, so I didn't put it in the service. We will talk about that actually in a few minutes. Yeah.
Okay. Cool.
But the pattern, I'm not sure how you if there is specific pattern for it.
Yeah, but it's authorization per service, right? Whether it's done inside or outside the service, each server has its own authorization model that can be enforced by maybe somebody else, but is dedicated to that service.
Yeah, I totally agree. Maybe there should be a name. Maybe we can invent one.
Yeah. Cool.
Yeah, so we discussed already the authorization is on the service. Sorry?
Yeah, go on.
The authorization is on the service level. In case it's not authorized, then you block the access. Here is an example of how you can see an application from security point of view. So you have input, then comes authentication, authorization, input sanitization, application logic, output sanitization, and the output. So what I assume here is that you do the authorization with UPA, and the authentication kind of lies in the access token. So we have a trust relation to the identity provider, and that means that we have kind of the authentication as an access token. And you have different contexts for your authorization. You have the user, the service, and the user and the service. So the user context here means that the user consumes a service and provides the access token, and then the service can validate this specific access token. And then afterwards, the service might request another service. And maybe that is we shouldn't discuss this here. Maybe they provide the same access token. That is a debate you can have for long if that is a good idea or not. Generally speaking, it's not a good idea, but we assume that you do that here. Maybe it's the same access token. Maybe you went to the identity provider and did how is that called, impersonation. So, but it still says it's for the same customer which requests here, and the next service also validates the access token again. So there is no trust that you say the other service did it already, so I don't need to do that. All the time you validate, is this token valid? Is the endpoint okay for this specific user to call? For example, when I say endpoint, I also mean a specific resource, because I assume that you do microservices correctly and you're using REST, and that means the resource you want to have is in the URL. So you do the authorization based on the URL here.
But in that case, right, you kind of want, you want to propagate the tokens that the user gives you, right, downstreams, because you don't know, what decision need to be made, right? And the token should not really have a lot of secrets, right? So you can propagate tokens downstream, or at least give downstream service a token that allows them to get more information, isn't it?
Yeah, you shouldn't provide more a token which has more information. Yeah. So what I said here is that you have a token which is again for the same one person which asks you in the front. So you don't have more privileges now, or you shouldn't have. So when you always, let us assume the case you're using the access token which the first service received, then the second service here receives the same access token.
Yeah, but the coolest thing of this, right, is that the service, even if your first service there is compromised, is not able to access every single piece of data, right? It's almost limited to whatever tokens you can see, and a vulnerability in that code doesn't allow the data to be exposed, right? Because the tokens won't work.
Yeah, that is correct. So that is from the security point of view a good thing. The bad thing is that the token might expire in case the other service is not available. But as I said, that is a discussion we better have in another talk.
Yeah, cool.
You also can have a service context. That is exactly what Denise, what you were heading to, where you have a badge job which has a lot of credentials. So you have here you use maybe the client credentials flow, and so that kind of means you can access all the data on the other service as a consumer. But again, the service needs to check: is a consuming service authorized to receive all of this data? Okay, and now we come to the user, to the context of a user and a service. So we have here a user on the left which wants to receive data from service A, and A then goes to service B. That is kind of what we saw beforehand. But now we have a second customer which goes to service B, not to service A, and then you need to request, then they both request service C. And maybe you, depending on your authorization structure, you want to deny this request because only service A is allowed to request service C. So that's what I mean, the context of a user and a service, because the service B requests data in the context of customer 2 here.
And in most applications, this is completely possible, right? Like without this, most applications allow service B to connect to service C. as long as network is possible. Like for example, Kubernetes, a lot of Kubernetes deployments, they have no isolation inside, right? So it's a crazy vulnerability, right? Because in this case, why should service B be able to connect and get data, right?
Yeah, absolutely. It doesn't make sense in a lot of cases.
Yeah, but in tons of cases, this is exactly what happens, right? Like this is exactly the problem that we're trying to solve.
Yeah.
Cool.
I think that is only done by training, right? To get into the head of the people, you need to authorize on service level.
But also to have vulnerabilities or have use cases that show why that's insanely dangerous, right?
Yeah, that's what I tried to show in the start, in my introduction. So I hope we are now all aware. So you can hand over this video later to your developers, and then they are also aware. All right. So what can you check on a service level, or is this are actually checks which you can also check tests which you can perform at the edge? So what you need to check is the signature, obviously. You need to check the expiration. That's very important. You might check, for example, not before. So is the token already be able to be used? And you might want to configure a leeway. So in case your clock is not 100% in sync with the clock of the identity providers, it might cause mismatches, especially with a not before claim. So a leeway is here to go. So you say, I accept plus minus 30 seconds, for example. Yeah, so this is basically what we discussed already. We have the user here providing a token going through the internet, then to a service. The service check, is the customer allowed to access information? And then the next service asks, is the customer allowed to access information? And is the service calling me allowed to access that information? Same for the for a batch job. Yeah, now we come to the details of the open policy agent. So you see here, how is it working actually? We heard already in the start that OPA is not is not something you directly put into the service. So how does it work? You have the service independent from the language. It performs a query that is basically an HTTP call to OPA, to the open policy agent, and then the open policy agent performs the decision based on the policy, which is defined in Rego, and on data, which is in JSON. And then OPA will give the decision back to the service. So let us have an example to have a better picture of it. So the request comes into the service, for example, get contracts. I have a lot of insurance customers, so that's why I chose an insurance related example. And the authorization is here, a JWT from the customer. and then it goes to the OPA. So the service performs a request to OPA, and you see on the left here the method is get, the path is contracts, and the JWT is set and set. Then OPA can, within the policy, we define that OPA decodes the JWT, gets the claim out, whichever the claim is, which it would like to have. Maybe it also validates the signature. If that is correct, that is something you can do in the service directly, or in OPA, that is a decision you should make. And then it can perform a validation if the access to contract to slash contracts is allowed. And in the policy, you have, for example, the input path should be contracts, and the advisor, which we can extract from the JWT, should be 1432. But that's very unhandy, right? To define in the policy 1432, the data might change every minute, every hour, every day, every week. So that comes very unhandy. So this is how you can define it. You can say jwt.groups should be equal to cadmins. And the cadmins are defined in the data structure, which has here 1432 or 3212 and so on. You see here that there is a wildcard. So the cart means we say whatever is defined in JWT groups should be an cadmins. So that is how you write it. That for example 1432 should be in this cadmins array.
Timo, a question. Have you seen a reference implementation of this in AWS, for example, where this will be an API gateway, a Lambda function? Because you kind of have the same patterns, right?
I haven't seen it as a Lambda function.
But this is the kind of stuff that we want to see, right? We want to see, for example, a Lambda function that is exposed via an API gateway, for example, the service, right? That expose that get contracts, and you want to kind of put the OPA call in the middle, right? So that you
I will tell you later about that. That is the envoy functionality, kind of.
Yeah.
Which you're talking, so that it's a sidecar before the actual service is getting called.
Yeah.
And I experience that with a customer, and we come to that later.
Okay, cool.
I also thought that is the way to go, but I can give you a preview. That is the worst thing you can do. Okay, let us continue with this example here. Maybe the service beforehand fetches some other information from a database or from whatever, and you can enrich the query with that data so that you have more data on which you can define, on which you can perform the policy decision. Yeah, this is the architecture you see on the left here. You can run OPA as a daemon, and as Denise already previewed, you can have it as an envoy. And the daemon one is what we saw beforehand. You have the service making an HTTP call to OPA. OPA performs the decision and so on. In the envoy example, we have the envoy. Mostly known from Kubernetes, where the envoy redirects the traffic first to the envoy filter of OPA, and then OPA performs the decision, and then the envoy will stop or will let the traffic pass through to the actual service. So what is the problem with this? What I have experienced is when we did this in a real project, is that OPA at this point doesn't have enough context information for 90% of the cases to say yes or no, because more data is needed. That was the problem. It wasn't enough data. So OPA, in that case, it means that we have enriched the customer So I wouldn't have done it like that. The customer enriched the request with HTTP fields with the data which the OPA needed in order to perform the authorization decision, and that didn't feel right.
So what you're saying is that on that envoy, because you're not in the application space or the web microservice space, you don't have set in the context, so you're not able to make specific calls that are web service specific.
Yeah, you would need to make now from this OPA do a lot of calls to outside to do your decisions. Yeah.
Yeah.
And then I think it's better to first go into the service. The service does it in a way the developers know, and then we give the data to OPA. So what another friend of mine, another security architect experienced with another product, not OPA, but another product, kind of the same thing. They experienced that they couldn't introduce this nice concept because they didn't handle timeouts and so on well. So when something unexpected happened, they couldn't do it in the authorization framework.
Okay.
So that's why I wouldn't fetch all the data within OPA. I would let the service do it and then give it consolidated to OPA. I think OPA, that is the German wording. Maybe you have to say OPA.
But then, but do you also have a version where instead of making that call, right, in your daemon or that, basically that microservice, the decision is made inside the microservice, but at the gate of it, almost like at the first layer of the microservice?
Yeah, in the first layer of the microservice, you should do that. Yes,
yeah.
That's how you do it.
Yeah.
I mean, or the first is a bit hard. You can perform, as I said, first the JWT check. Is it what I expect? Is it valid, and so on? What I mentioned already. Then you might fetch the data needed to perform the decision, and then you go into OPA.
Yeah. Cool.
And here is how you can see how to configure, for example, in Java that you would like to call OPA. So you have here in the web security configuration, you can just add a configuration so that you call an access decision manager, which basically is in the end OPA, as you can see down here, the access decision voter, and then you call HTTP localhost 8181 and so on. OPA, in case you run it, in case you run OPA in Kubernetes, you can run it as a sidecar, so that the microservice can call it. So that means it's decoupled from the service and the microservice can be exchanged. And we have some other, so this is one of the most important slides I have here, because when you understand the concept of OPA, now you understand why it might be helpful for you to do so. So you're detaching the authorization logic from the business service. So that means that access tokens you only need to look at in OPA. You don't look at it again in the service because you expect it's already, you performed the authorization already, and that you can now do your business logic. That is especially interesting for software development companies where the service runs, the actual service later will run in an external infrastructure. So as a software development company, you need to say how do you do your authorization, and every of your customer will have different claims. For example, some will have UID for the users, some will have user ID, and so on. And in this way, you can detach this authorization logic from the external logic. You can also gain benefits, at least that is what the developers tell me, what they say. Integration tests can focus on the logic because you can remove the authorization logic completely. It doesn't mean that you don't test for authorization. I also recommend to have an extra integration test where you actually test also a bit of your OPA configuration. And as you write your code in Regio, in the Rego language, you can write there also tests, unit tests directly in Rego. And yeah, that is something, Denise, which you mentioned beforehand. So in case you want to kind of automate, is this service having authorization logic or not? You can search for a Rego file via the GitHub API, for example. In case it doesn't exist, it means that the service doesn't have authorization, at least not through OPA. You can also audit these Rego files very easily. I'm good in reading it, so I understand what the developers are doing. I'm not so good at writing it. Yeah, but that is that are from my point of view the advantages why you should do OPA. OPA, the Rego language is very difficult to write from my point of view. I performed with one customer a test of the pods which are deployed in Kubernetes. So we tested, are they deployed in the way we expected? And we tried it first out with OPA and afterwards with Kuverno, which had a different language. And in the end, we decided for Kuverno because the language was easier to grab for us. So OPA needs some time until you understand the Rego language behind it.
Yeah, so I completely agree, man. That's one of the most important slides. Now, have you seen the visualization of those Rego files? Like, because I think one of the things I feel is insanely powerful with this is that what you also have in those files is the business logic of the application, right? Is basically how data flows and how the application structure, fundamentally who's talking to who, right?
You can't say who is talking to who. Yeah, in case you also do it for on that you say I expect this client. Yes, then you can say this service can talk with me. Yeah. I would say it's more the job of these open API specifications to define it in a more granular way. But for the authorization logic, you have everything in the Rego files. Yes.
Cool. And then the other thing that I was thinking is, have you seen a mapping of this into things like the NIST framework and other maturity models? Because one of the things that I'm trying to do is also create standards and creating, almost not barriers of entry is probably not the best word, but to say, the services to be secure should have a certain amount of properties, right? And the reason they have those properties is because you want them to be compliant with, for example, a particular standard or a particular maturity model or a particular NIST framework or ISO 27000 or some of the controls, and then be able to say, and if they have this, they are compliant, right? Because at least they follow in the best pattern. If they don't do this, then they should be doing equivalent stuff.
And yeah, what we have is a request for comments, right? Here. So it's kind of defined in there. So you can say, please do your authorization based on FC 2904. And then they will have to decide what they use. And maybe it will be OPA.
Yeah, but you see that the power of linking to the standard, right, is that then it becomes something that can be enforced and monitored right across web services.
Yeah.
Yeah. Cool. I mean, no, good stuff. I think the visualization is going to be really cool, man, because I feel that this is also one of those areas where, it can add a huge amount of value to business, like just to developer teams that sometimes might not have the most up-to-date diagrams and the most up-to-date documentation.
Do you mean you want to see code, or do you want to see, what do you mean by visualization?
Well, those files, if that mapping you're saying, those Rego files define the service, who can do what's the accesses, what's the data points, who can call who, because eventually you're going to go into, more part of the business logic. You actually are seeing how the application works.
Yeah, we can take, as you can have seen, we skipped now around 30 slides.
YBL.
So here we are having, this is actually one of my, it's for the workshop. I did that together with one of my clients, SDASE, where we do this as a workshop, right? So people have to change this. So this is not a good example. This is a bad example. And now people have to analyze it and understand why it's not working. I think it's not working by default yet, because there are some things not working. So our task is to fix it. But we can learn from it. So what you see here, this is the input from the service to the OPA. Here, no data is defined, and this is the policy. So you see here that we decode the header. By default, we have a rule here which is false by default. Then we have another rule here which is defines my rule as true, and then we have another my rule here. Yeah, now the next question I think from you should be, is this and or these different blocks? And I think for that we go back into the slides here. So these are all different blocks, and these blocks are mixed with an or operation, and everything within one of these blocks is an and operation. Is that what you wanted to hear?
Yeah, no, that's really cool, right? But it'd be good to get some graphs out of that stuff, right?
So I will go back to explain a bit more about OPA, and then we can see later if we have time for some of the tasks. But the slides look already like, I think we won't have time to actually do hands-on, but you will understand a bit better how you can make use of OPA, because the deployment is a bit, you need to understand the deployment to make your decisions where you put large data, for example, and how do you make it accessible to OPA. So how do you distribute policy and data? You have the option to do it during the deployment with a config map. For example, when you are in Kubernetes, you can do it with a config map, or you can use it as a bundle. And the bundle means that it's that OPA will make an HTTP request to the bundle server and fetch the data. Config maps can be mounted in OPA very easily.
I'll just park here. You can say.
And OPA has also an auto update feature, so that it automatically updates when there is something changed in the volume. Denise, do you mind to turn off your microphone while you are parking?
Yeah. Cool.
In the bundle, when you use the bundle, that is mainly for big data. Then you in the bundle provide data and policies together in one folder. OPA will pull that data in a defined iteration. That also means that it's a very critical point in your infrastructure, because compromising of the policy and data provider service means that you get access to the authorization system. So you need to make sure that that is a well-patched, for example, a well-patched and secure configured service which provides that data. You have the use cases of dynamic data and large data. An example would be the relationship between, from insurance point of view, from a contract to one of the advisors. The structure of the bundle is that you have a folder, and then you might have different subfolders for different policies, and in that subfolders you have a policy.rego file in which you have your policy configuration. You have a policy underscore test rego file in which you have the tests for that policy, and a data JSON in which you provide all the different data which the policy needs to perform the decision.
And Rego are JSON files, right? You showed before, right? They have that. Oh, YAML files, sorry, right?
Yeah, it's not YAML, I would say. I wouldn't say it's YAML. You see it has its own structure, kind of. But yeah, it's maybe JSON-like or YAML-like. You see here.
What language is this? This feels like.
Yeah, Rego is its own language, right?
Oh, okay. Fair enough.
It's that's
looks a mix of Python and Node, right? Kind of. Okay, fair enough. But the coolest thing is that this can be version control, right? This is like goes in GitHub repos and is human readable and machine readable, right?
Absolutely, yeah. You directly put it like that in your Git repository. Here is such a configuration for one of the bundles. You have you define his services, and you can say this is my contract bundle, and it's available under this and this URL, and you want to pull it so and so often, and the resource is a bundle tar. And then OPA will automatically pull the bundle.targ.gz for you between 10 and 20 seconds, every 10 and 20 seconds. So the preferred way from what I experienced so far, and my customer is the ASE also, is that config maps are the preferred way, but for large data you need to you should use a bundle. So there's also a page, a documentation page from OPA, which highlights that the different use cases in much more detail than I'm doing that here, where you can grab more ideas when to use what. Yeah, so the key assumption is that every domain can be represented in a structured way, and that policy is logic applied to data.
So here's a question, man. Can you write tests for those Rego files?
Yeah, otherwise an Rego._test file wouldn't make sense, right?
Exactly, right? You want to make sure you write tests, or else you are one little mistake, a fat finger to creating a massive vulnerability, right? You want to have tests, but I guess Rego file is possible. Is there such a thing as tests, Rego tests?
Yeah, absolutely. There is such. I can go to one of my last examples here. There are different types of tests you can. So here, you see
amazing feature, right? Because a lot of security controls, not only a map, they completely not testable, right? So we can actually write tests to confirm what we want to do, right?
Yes. Yeah. There are some tricks you need to do. For example, JWT is not signed here, but you can just create it on JWT.io, or you can save create it, and then you put the created JWT here for the tests with the data you expect, and then you can perform the tests here.
That is really cool, man. No, that's why we need a maturity model, man. So we can just basically ask those kind of questions. So do you have a central per service authorization model? Check. Do you have a way to capture your authorization in version control? Check or not check, right? Do you have a way to test your security policy? Check, right? And most applications are going to be no, right?
Yeah.
But it's a way to drive change, right? Because then you can start to put policies, right? You can start to put, like, for me, what I found really interesting is I want to get to a model where some of the key assets are protected by something like this. So you start to say, if you want to access those key assets, then you have to talk like this. Do you know what I mean? It's almost like use the assets to drive security standards, use the assets to drive the best practices, because once the core asset supports this, you can make it a requirement to talk to it to actually behave the same way.
Yeah. Yeah, I think that's a DevSecOps maturity model where I, by accident, also the leader, doesn't go in so much detail, but a pull request from you is very welcome.
Yeah.
And then you have it, right? And you can show it to your people, and I expect now that you do this.
Absolutely. Well, I'm hiring my head of AppSec, man.
Okay, I think we have 10 minutes left. Are there people here with questions?
Let's take a look. Let me get the chat. No, I don't think any questions so far.
Then I go ahead with some context, right? So here's where we stopped. Can customer X do operation Y on resource Z, and which records should Bob be allowed to see? That are the questions you might ask. Rigor is a decorative language. That means you need to describe what you want to have and not how you want to have. Other examples for this type of language are SQL queries, where you see one here, or XML. So that makes the shift in the head so hard, at least for me, to express what I want to have. Maybe you have different requirements from the business, like only the owner can update the pet's information, and from OPA, you need ownership information, which is provided as input to OPA.
But going back to that thing about the tests, we could write tests to do this, right? So you almost can write tests that run against those files, Rego files, that then allow us to codify these business requirements.
Yeah, and in the best case, you write the test before you write the authorization.
Yeah,
logic.
Absolutely. Yeah,
best case. I think that is very clear for the people here, negative and positive lists. Application-based implementation, you see one example here. You describe the package, then you describe that the default is that allows false, and then you make another block with allow, where you have the input method is put, where you have where you define a variable. Then you check if the input path is pets/pet ID, and then you check if the input user is the same as the input owner. So that is an example I took from the Open Policy Agent documentation. That's a very simple one. That's what I described. Another example is what we see here, which you can use when you have an envoy. Then you need to define it a bit different than the envoy sends it to you. So the structure is a bit different. So you have input attributes request HTTP message to define the method. You can also create a variable, right, for this input attributes request HTTP message in case you want to call that multiple times, or for the path here, which that is more likely that you want to have multiple times check the path in one file. This is an example in case you want to use the admission controller of Kubernetes and you would like to define which images are allowed and which images are not allowed. And then you can say here, you need to swap now. Before and it was allow is denied, and here you have deny. and you have a kind here. So for the kind pot, you might have other kinds in Kubernetes, right? Like secrets or deployments or all the other things. But here it only applies to pod. And in case the image is input request object specification containers, one of them, and then the image doesn't start with image is registry Pagel Pro, then it gets denied with the message. The image, whatever it is, comes from untrusted registry, and then the registry name is here for the V. The image name, sorry. OPA also performs some speed optimization to let the authorization decision come as quickly as possible. So it creates a tree, and then it tries to identify to try to go the right path for the decisions. As we discovered, Rego is mostly unknown in the first place, but when you use it, especially in different components, like for the service, to perform authorizations for Kubernetes and so on, then you build up some Rego knowledge, and then it becomes very known to the organization, and you can easily write such policies. Yeah, and that's it for today. I hope you got a nice overview of OPA, and you might start to implement it in one of your services.
No, this was great, man. No, it's really good. And another one for the OPA knowledge base. Absolutely, great stuff. We need to get some forum, man, of OPA users, right? To have a almost like a conversation about best practices and how to use it, and life examples of people that try to use it. So maybe a good session for next time.
Yeah, maybe a session for next time. Yeah,
exactly. Brilliant, man. All right, thanks a lot, and I'll see you on the other sessions.
Thank you. Bye.